Hello Year 12, welcome to the second video here for our fourth topic, the normal distribution. We're looking at Z-scores today. Now Z-score is sometimes called a standardised score. Perhaps you've heard that language before. Well, you won't hear it too much anymore. We're going to keep using the language Z-score, but essentially what a Z-score is a measure of how many standard deviations a single score within a data set is above the mean. So a Z-score of 1.6 means that that score is 1.6 standard deviations above the mean. Rightio. Now we've talked about mean, standard deviation, normal distribution, this empirical rule with the percentages under there and whatever else. Let's jump straight through to an example. There are some formulas here and they're perfectly fine, but I'm pretty confident that that idea of how many standard deviations above the mean pretty much speaks for itself. So I have 600 ml cartons of milk, normally distributed. Right, if it doesn't say that, we can't use any of these rules with standard deviation and empirical rules and all that stuff. But the mean is 600. So x bar equals 600. Wonderful. Standard deviation, let's put the S in here. Standard deviation equals 5. So Z-score for 610. Well, how many standard deviations? So is this above or below the mean? It's above the mean. By how much above the mean? It's 10. 10 mils is how many standard deviations? Well, if the standard deviation is 5, then 10 mil is 2 standard deviations above the mean. So by that logic, 610 mils has a Z-score of 2. But if we use the formula, I'm going to say Z equals my score minus the mean. So that's 610 minus 600. Divided by a standard deviation of 5, right? So therefore my Z-score is 10 over 5 equals 2, right? Just like that. Now for the second one here, 596. Well, it's less than the mean, so it's going to have a negative Z-score. It is 4 mils less than the mean, so that's less than 1 standard deviation below the mean, right? How much of a standard deviation? That's 80%, a 0.8 of a standard deviation. So this should have a Z-score of negative 0.8. But here's the formula, Z equals, now the score minus the mean, 596 minus 600, which is what gives us a negative Z-score, tells it's below the mean, divided by 5 equals, now you can punch it into your calculator if you wish, but of course it is negative 0.8. There we go. Z-scores. Moving along, we've got a little bit extra here. What amount of milk has a Z-score of 1.5? So it's positive. It's 1.5 standard deviations above the mean. It is 1.5 lots of 5. That's 7.5 mils greater than my mean of 600. So that must be 607.5 mils. But nonetheless, let's have a go with the formula as well. So I'm going to say my Z-score is 1.5 equals my score, which I don't know, minus the mean of 600 over the standard deviation of 5. Now, if we solve that, I do 5 times 1.5 equals x minus 600. Therefore, x equals 5 times 1.5 plus 600 equals 607.5 mils. There we go, like that. Now, negative 2.6. Negative 2.6. So we are 2.6 standard deviations below. 2.6 standard deviations is 2.6 times 5, or I guess it's 1.3 times 10. So that is 13 mils below the 600. So it should be 800 and... well, not 800, it should be 587 mils. Negative 2.6 is my score, which I don't know at this stage, minus my mean that I do know of 600, divided by a standard deviation of 5. Therefore, x equals 5 times negative 2.6 plus 600 equals, what did I say it was, 587 mils. There we go. One more to go here, I think, and we'll be done. What percentage of cartons have less than 590, oh no, we've got a bit more to go, 590 mils of milk? Well, we need to apply our empirical rule from the previous question here when it says what percentage, right? Now, I first of all need to identify what the z-score is here. So I'm going to say that z equals my score, 590, minus my mean of 600, divided by my standard deviation of 5, is negative 10 over 5. So that's a z-score of negative 2. Now, I really like, whenever I'm doing these percentages, draw your curve. Ooh, that's pretty lopsided. That's pretty skewed, as we would say. All right, there are my 34s. 13.5. Should be a lot more symmetrical than this. That's a pretty poor sketch. 2.35. And, oops, I don't want a line there because this is all the rest is 0.15. 15. Now that takes a little while, but it certainly makes it easier to answer these. My mean is 600. My standard deviations are 5. So 605, 610, 615, 595, 590, 585. Now I'm talking about less than 590. Right, here's my z-score of 2. Oh, did I need to work my z-score of negative 2 out? Probably didn't, but nonetheless it sort of clarifies things a bit. If we get a z-score that's not an integer, in fact, that's not an integer between negative 3 and 3, we don't know how to apply the empirical rule to those sorts of things. We're not going to learn about that. Right, so I've got this part here, and I can see it's 2.35, and 0.15 is 2.5%. Now, somewhere you need to show your working here. This probably is enough to show you working. This, I think, is a good way. Like, this is your working for this question. This shows that you understand here's two standard deviations, less than 590, and my percentages that I'm adding together. So 2.5% of cartons. Yeah, working in for the rest. Rightio. Now, we do have another example here. Let's have a look. Oh, gee. Here we go. Packets of muffin mix, normal distribution, that's important. Mean of this, x bar equals 432. And my standard deviation, I'm going to use a little s this time, equals 2. Complete the table. Right. So a z-score of -1. I don't really want to do my working here. We're just going to do this in our heads. So a standard deviation, a z-score of -1 is one standard deviation below the mean, so that's 2 less than this is 430. And this is obviously 2 less, so that must be a z-score of -2. 434 is one standard deviation above, so that's a z-score of 1, and a z-score of 2 will be an extra 2, or in fact it will be 4 grams greater than the mean, is 436. That's nice, that's pretty easy. What percentage of packets will have a net weight of these, right? Once again, we have to do this, or I very strongly recommend the curve. It takes a while, undoubtedly. It takes a little while. You'll get faster at it, but even once you're fast, I still recommend you do it. 13.5, it doesn't take that long. 2.35, 0.15, 13.5, 2.35, 0.15. Right, my mean was 432, 434, 436, 438, is that right? Yep. And going backwards, 430, 428, 426. Right, greater than 432. Oh, here we go. That's our mean. So 50%. Oh, my line moved there. Didn't want that to happen. 50% will be greater than 432. That's our mean. Between 428 and 434. 428 and 434. Oh, here we go. Now that's actually a number that crops up a bit. This is part 2. I'm going to say it's 34 plus 34 plus 13.5 equals 81.5%. Nice. packets are labelled net weight 430 grams? Yes. What percentage of packets will have a net weight less than 430? So now I'm after... This one's here. Man, that is a noisy car. The bike. 1, 2... Oh no, that's part C, not part B. Not part 3. Part C here is this one here. So we've got 13.5% plus 2.35% plus 0.15% is 16% of packets will have a net weight less than 430 grams. There we go. That's it for Z-scores. That's our second video. Hope you enjoyed it. If you've got any questions, jot them down. Ask me in class. See you then, people.